Language modeling is compression. It has long been established that predictive models can be transformed into lossless compressors and vice versa. Incidentally, in recent years, the machine learning community has focused on training increasingly large and powerful self-supervised models. Since these large language models exhibit impressive predictive capabilities, they are well positioned to be strong compressors. In this work, we advocate for viewing the prediction problem through the lens of compression and evaluate the compression capabilities of large models. We show that large language models are powerful general-purpose predictors, and that the compression viewpoint provides novel insights into scaling laws, tokenization, and in-context learning. For example, Chinchilla 70B, while trained primarily on text, compresses ImageNet patches to 43.4% and library speech samples to 16.4% of their raw size, beating domain-specific compressors like PNG, 58.5%, or FLAC, 30.3%, respectively. Finally, we show that the prediction compression equivalence allows us to use any compressor, like ZIP, to build a conditional generative model. OpenBA, an open-sourced 15B bilingual, asymmetric SEC-to-SEC model pre-trained from scratch. Large language models, LLMs, with billions of parameters, have demonstrated outstanding performance on various natural language processing tasks. This report presents OpenBA, an open-sourced 15B bilingual asymmetric SEC-to-SEC model, to contribute an LLM variant to the Chinese-oriented open-source model community. We enhance OpenBA with effective and efficient techniques, as well as adopt a three-stage training strategy to train the model from scratch. Our solution can also achieve very competitive performance with only 380 B tokens, which is better than Llama 70B on the Bellabel benchmark, Bloom 176B on the MMLU benchmark, GLM 130B on the C-eval hard benchmark. This report provides the main details to pre-train an analogous model, including pre-training data processing, bilingual FLAN data collection, the empirical observations that inspire our model architecture design, training objectives of different stages, and other enhancement techniques. We have refactored our code to follow the design principles of the Hugging Face Transformers library, making it more convenient for developers to use and release checkpoints of different training stages at the project's website. More details of our project are available at the project's GitHub repository. Multimodal Foundation Models, from Specialists to General-Purpose Assistants. This paper presents a comprehensive survey of the taxonomy and evolution of multimodal foundation models that demonstrate vision and vision language capabilities, focusing on the transition from specialist models to general-purpose assistants. The research landscape encompasses 5 core topics, categorized into 2 classes. We start with a survey of well-established research areas. Multimodal foundation models pre-trained for specific purposes, including 2 topics: methods of learning vision backbones for visual understanding and text-to-image generation. 2. Then we present recent advances in exploratory open research areas, multimodal foundation models that aim to play the role of general-purpose assistants, including 3 topics: unified vision models inspired by large language models, LLMs, end-to-end training of multimodal LLMs, and chaining multimodal tools with LLMs. The target audiences of the paper are researchers, graduate students, and professionals in computer vision and vision language multimodal communities who are eager to learn the basics and recent advances in multimodal foundation models. Baichuan 2. Open large-scale language models. Large language models, LLMs, have demonstrated remarkable performance on a variety of natural language tasks based on just a few examples of natural language instructions, reducing the need for extensive feature engineering. However, most powerful LLMs are closed source or limited in their capability for languages other than English. In this technical report, we present Baichuan 2, a series of large-scale multilingual language models containing 7 billion and 13 billion parameters, trained from scratch on 2.6 trillion tokens. Baichuan 2 matches or outperforms other open-source models of similar size on public benchmarks like MMLU, CMMLU, GSM 8K, and Human Evil. Furthermore, Baichuan 2 excels in vertical domains such as medicine and law. We will release all pre-training model checkpoints to benefit the research community in better understanding the training dynamics of Baichuan 2. SlimPajama-DC, Understanding Data Combinations for LLM Training. This paper aims to understand the impacts of various data combinations, for example, web text, Wikipedia, GitHub, books, on the training of large language models using SlimPajama. SlimPajama is a rigorously deduplicated multi-source dataset which has been refined and further deduplicated to 627B tokens from the extensive one. 2T tokens. Red Pajama dataset contributed by Together. We've termed our research as SlimPajama-DC, an empirical analysis designed to uncover fundamental characteristics and best practices associated with employing SlimPajama in the training of large language models. During our research with SlimPajama, two pivotal observations emerged. 1. Global deduplication versus local deduplication. We analyze and discuss how global, across different sources of datasets, and local within the single source of dataset deduplications affect the performance of trained models. 2. Proportions of high-quality/highly deduplicated multi-source datasets in the combination. To study this, we construct 6 configurations of SlimPajama dataset and train individual ones using 1. 3B Cerebra's GPT model with Alibi and Swiglio. Our best configuration outperforms the 1. 3B model trained on Red Pajama using the same number of training tokens by a significant margin. All our 1. 3B models are trained on Cerebra's 16 times CS2 cluster with a total of 80 PF-LOP-S in BF16 mixed precision. We further extend our discoveries, such as increasing data diversity is crucial after global deduplication, on a 7B model with large batch size training. Our models and the separate SlimPajama-DC datasets are available at the project's website. Stabilizing RLHF through Advantage Model and Selective Rehearsal. Large language models, LLMs, have revolutionized natural language processing, yet aligning these models with human values and preferences using RLHF remains a significant challenge. This challenge is characterized by various instabilities such as reward hacking and catastrophic forgetting. In this technical report, we propose 2 innovations to stabilize RLHF training. 1. Advantage Model, which directly models advantage score, that is, extra reward compared to the expected rewards, and regulates score distributions across tasks to prevent reward hacking. 2. Selective Rehearsal, which mitigates catastrophic forgetting by strategically selecting data for PPO training and knowledge rehearsing. Our experimental analysis on public and proprietary datasets reveals that the proposed methods not only increase stability in RLHF training, but also achieve higher reward scores and win rates. Q-Transformer, Scalable offline reinforcement learning via autoregressive Q functions. In this work, we present a scalable reinforcement learning method for training multitask policies from large offline datasets that can leverage both human demonstrations and autonomously collected data. Our method uses a transformer to provide a scalable representation for Q functions trained via offline temporal difference backups. We therefore refer to the method as Q-Transformer. By discretizing each action dimension and representing the Q value of each action dimension as separate tokens, we can apply effective high-capacity sequence modeling techniques for Q learning. We present several design decisions that enable good performance with offline RL training and show that Q-Transformer outperforms prior offline RL algorithms and imitation learning techniques on a large, diverse, real-world robotic manipulation task suite. The project's website and videos can be found at the project's website. $360 circumflex circ dollar reconstruction from a single image using space-carved outpainting. We introduce POP 3D, a novel framework that creates a full 360-degree view 3D model from a single image. POP3D resolves two prominent issues that limit the single-view reconstruction. Firstly, POP3D offers substantial generalizability to arbitrary categories, a trait that previous methods struggle to achieve. Secondly, POP3D further improves reconstruction fidelity and naturalness, a crucial aspect that concurrent works fall short of. Our approach marries the strengths of four primary components. 1. A monocular depth and normal predictor that serves to predict crucial geometric cues. 2. A space-carving method capable of demarcating the potentially unseen portions of the target object. 3. A generative model pre-trained on a large-scale image dataset that can complete unseen regions of the target. And 4. A neural implicit surface reconstruction method tailored in reconstructing objects using RGB images along with monocular geometric cues. The combination of these components enables POP3D to readily generalize across various in-the-wild images and generate state-of-the-art reconstructions, outperforming similar works by a significant margin. Project page, project's website. FoleyGen, visually guided audio generation. Recent advancements in audio generation have been spurred by the evolution of large-scale deep learning models and expansive datasets. However, the task of video-to-audio (V2A) generation continues to be a challenge, principally because of the intricate relationship between the high-dimensional visual and auditory data, and the challenges associated with temporal synchronization. In this study, we introduce FoleyGen, an open-domain V2A generation system built on a language modeling paradigm. FoleyGen leverages an off-the-shelf neural audio codec for bidirectional conversion between waveforms and discrete tokens. The generation of audio tokens is facilitated by a single transformer model, which is conditioned on visual features extracted from a visual encoder. A prevalent problem in V2A generation is the misalignment of generated audio with the visible actions in the video. To address this, we explore three novel visual attention mechanisms. We further undertake an exhaustive evaluation of multiple visual encoders, each pre-trained on either single-modal or multimodal tasks. The experimental results on VGG sound dataset show that our proposed FoleyGen outperforms previous systems across all objective metrics and human evaluations.